this lesson is on adding rational and irrational numbers. So first we're going to look at what those two words mean, rational and irrational, and then we'll look at adding them together. So first we're looking at rational numbers. A rational number is any number that can be written as a ratio or fraction. And you can remember that because the word ratio is right in the word. So a few examples are 1/2, 8 1/25, 1/3, 3,227 555. Basically anything that has a numerator and a denominator is a fraction, and so it's a rational number. So when you write these rational numbers as decimals, sometimes they end or terminate. For example, we've all seen that 1/2 equals 0.5 and 8 over 125 equals 0.064. And these numbers just end. I didn't round them at all. They just stopped. And so when they just end like that, they're called terminating fractions. Some other rational numbers just repeat or go on forever. So the most famous one is this first one, 1/3 equals 0.33333333, and you could keep saying the threes forever. They just repeat and go on and on and on. Another one is 3,227 over 555. That equals 5.8144144144144, and again, the 144s will go on forever. So both of these sets, the terminating or the repeating, they're both rational numbers because they both can be written as fractions at the same time. The other type of number is irrational. And here the "ir" in front of it means not, or not rational. So it makes sense that this means numbers that cannot be written as a ratio or fraction. And we haven't seen as many of these in the problems that we usually do, but a couple examples are pi and square root of 2. And you can see that they can't be written as a fraction with an integer on top and an integer on bottom. It's just not possible when they're irrational. And when you write these as decimals, they go on forever, but they don't repeat or have patterns like we saw before. Like, for example, pi is 3.141592, blah, 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 blah. It keeps on going on, but it doesn't repeat ever, and there's no pattern. The numbers just go on forever with no pattern at all. The same thing with square root of 2. It's 1.41421, and it keeps on going. The numbers will go on forever, but there's no pattern or repeating in there. So that shows that these are irrational. Now, mathematicians know both of these groups, and they kind of look at what happens when you add them together. The first thing that they like to look at is adding two rationals. They say if you have one rational number and you add another rational number, what kind of number are you going to get? So an example of this is problems that a lot of people learned in elementary school, just one fraction plus another fraction, because fractions are both rational. So a lot of people will remember to add fractions, you just need to find a common denominator. Here you have an 8 and a 4, so the common denominator can be 8. The first fraction will just stay 1/8. The second fraction you need to multiply by 2, because 4 times 2 is 8. So 3 times 2 is going to be 6, our new numerator. And then we just add those numerators up. So our answer will be 7/8. Another example of a rational plus rational is two more fractions that you can add together. Here we have 2 over 3 plus 3 over 5. So since the denominators are 3 and 5, our common denominator will be 15. And 3 times 5 is 15, so 2 times 5 is going to be 10. 5 times 3 is 15, so 3 times 3 is 9. And when we add those numerators, we get 19 over 15. That's the same thing as 1 and 4/5. And most of you recognize this process, and you remember from elementary school that any two fractions you get in the beginning problem You can find the common denominator, add them together, and get a fraction for the answer. So even if you had letters standing for the numbers, like you had a problem a over b plus c over d, you know you're adding two fractions, and so you're always going to get a fraction for the answer. Here we can just say e over f. We don't know exactly what numbers we're going to get, but we know it's going to be a fraction. So looking at this, we're saying we're starting with a rational, adding another rational, and we're getting a fraction. And we know fractions are rational. So then it makes sense that rational plus rational always equals a rational. So another way of saying it would be a fraction plus a fraction always equals another fraction. So the next question that mathematicians ask themselves is, what if we add a rational and an irrational? What kind of number would we get then? And so they kind of experiment around and try some things. Oftentimes the first thing that they would try is saying, let's just try and see if we can get a rational. If we add a rational and an irrational, is it possible? And since we don't know for sure if it's possible yet, we're still going to keep the question mark over the equal sign. Just to say we're not sure if they're equal, we're going to test it and see. So they write an example. They know that a rational can be written as a fraction, so they write rational as a over b, because it can be any numbers. And our second rational is going to be c over d, just to say, again, it's any numbers, but it has to be a fraction. And the middle part is a little trickier, because you can't write an irrational as a fraction. That's the definition of it. So here we're just going to use this fancy x. The x has to be irrational, and to remind us of that, there's also a pi sign, square root of 2. It's any one of those different numbers that cannot be written as a fraction. So remember, we still don't know if this is true or possible, so we're going to keep that question mark over the equal sign. And then mathematicians would try and solve it and see if this is possible. So if you want to get this irrational fancy x by itself, you need to get rid of everything else on that side. So you need to get rid of the a over b. To get rid of plus a over b and solve this equation, you need to get rid of it or subtract it. So we can subtract a over b from both sides. And we know that if we subtract it, it's gone from that side. And on the right side, we would have c over d minus a over b. And we can't do this math because we don't know what any of these letters stand for. But we do know from before that whenever we subtract two fractions, you're going to get another fraction. So we can pick some new letters to symbolize that. Let's say e over f. We just know it's going to be some fraction that we don't know what the numbers are. So once we do this math, we're left with this irrational number equals e over f. And remember, we're not sure about this yet. We still have our question mark. So we need to think, is it possible that this is true? Is it possible that an irrational number like pi square root of 2 can equal the fraction e over f? And if we remember the definition of an irrational, it means it cannot be written as a fraction. So it cannot be written as the fraction e over f. It can't be written as any fraction. So this is not true. A rational plus an irrational cannot equal a rational. All this whole thing was false. If it's false, the last question we need to ask is, what is true? It would have to be the opposite. A rational plus an irrational must equal an irrational. So in this lesson, we've learned two new rules. A rational, or a fraction, plus another rational, or another fraction, always equals a third fraction. Secondly, a rational number plus an irrational number always equals an irrational number. Now your job after watching this video is to consider multiplication. So consider what happens if you multiply a rational times a rational. What kind of number do you get? And then secondly, what happens when you multiply a rational times an irrational? What kind of number will you get? Consider that. Make a few examples and make a video of your own proving the rules that you discover.